This is mathematics lesson for grade 8, and this program is organized by Addis Ababa City Administration Education Bureau in collaboration with Addis Media Network. I'm the presenter, Teacher Mamo. I will be presenting grade 8 mathematics. Well, so today we will have a discussion on the applications of squares, square roots, cubes, and cube roots, which will be the last topic on the second unit. Okay, so 2.3 is about applications of squares, square roots, cubes, and cube roots. So this will be our point of discussion for today. If you remember, in our previous class, we have seen the concept of squares, square roots, cubes, and cube roots. Okay, so we have seen this concept in 2.1 and in 2.2, and we have also seen how a number can be squared, how square roots can be calculated, and we've seen also how cubes and cube roots can be calculated for different rational numbers. Okay, that was the point of discussion that we had in our previous lesson, right? So today we will see the applications of squares, square roots, cubes, and cube roots. Okay. In our day-to-day life activity, we apply these concepts almost everywhere. For example, if you want to calculate the area of your room, you use squares, right? You use squares. So this concept can be applicable in carpentry, engineering, in design and construction. So this concept is widely used in our day-to-day activity. So in this lesson, we will be focusing on some of the applications of squares, square roots, cubes, and cube roots. Okay, so before looking at the examples regarding this topic, I want to tell you some of the concept of squares and how we can apply it. And I will also tell you the relationship between a cube and its side, right? So, geometrically, a square is a four-sided polygon, okay? Geometrically, a square is a four-sided polygon. Each of the adjacent sides form perpendicular. Okay, this is one characteristic of a square. The other thing, this regular polygon is called a square if each sides are the same. Okay, this is roughly a geometric shape of a square. So if the length of the side is x, so this will be x, all the sides becomes x. Okay, so we can create a relationship between the side and the area of a square. Okay, so area is calculated as length times width, right? But here the length and the width are the same, which is x. So the area becomes x times x, which is x squared. Okay, so there is a relationship between the area and the side of a square. So that relationship is a is equals to x squared. Okay, you need to have this relationship to understand the area of a certain square region, right? The other thing, if a is x squared, you can express the side in terms of the area, right? So taking both sides by radical, this gives us x is equal to square root of a. Okay, these two equations have the same meaning. Okay, you can use area is equals to x square. Area is equals to x square whenever you want to calculate the area of a certain square region. Whenever you want to calculate the side of that region, you can use x is equals to square root of a. Okay, so having this, we will try to see some examples regarding the applications of a square. So let's see a certain example. Example 1. Example 1. Alamu wants to construct a square patio. He has a concrete to make the patio with area 400 square meter. Okay, look at this example. In this example, there is a certain real-life scenario which is about the Alamu's case. Alamu wants to construct a square patio. He wants to construct a square patio, and he has also a concrete to make a patio with area 400 square meter. Okay, we have this. So having this, find the length of the patio. Okay, based on this information, here we are asked to find the length of the patio, or the length of the side of the patio. So to find the required length of the side of the patio, you need to apply the equation that we derived from the area formula here. Okay, so here is the procedure. Okay, what is given? It's given that the area of the square patio is 400 square meter. Okay, here I used SQM to shortly represent square meter. Okay, you need to understand in this way, whenever I say SQ.M, shortly I mean to say that square meter. Okay, so in this case, what is given, the area of the square patio is given, which is 400 square meter, right? The required thing is the length of the side of the patio. So say let the length of the side of the patio is x. If you represent the length of the side of the square patio by x, now you can easily find the required thing. Here, the required thing is x. Okay, x is required. So apply the second formula. X is equal to square root of a. So our a here is 400 meters square. So you can substitute 400 in place of a. Square root of 400 meters square. In our previous class discussion, we have seen how to calculate squares and square roots. Okay, apply the concept that we have used in our previous lesson. So a square root of 400, you can write 400 in the form of a certain perfect square, which is 20 square. Okay, to easily understand this, in place of 400, you can use 20 square meter square. 20 square means 20 by 20, which is 400. So now the square root of this number is 20 meter. Okay, so this 20 is the length of the side of the square patio. Okay, this is one of the example of the applications of squares. Okay, let's see another example. In the second example, if the side of a square is 5 meter, find the area of the square, the area of the square. Okay. Look, in the previous example, we've seen one application. In that application, the area was given, and we were able to calculate the side. Okay. In the second example that we have here, the side is given, and you are asked to calculate the area, right? So in this example, there is a certain square whose length of side is 5 meter. Here, we are asked to calculate the area of the square. Very simple. So we use the formula that we have seen before. Okay, if you want, you can roughly sketch the geometric representation of the square. Okay, you can roughly see or you can roughly sketch the geometric representation of the square if you want. It's not a must to sketch the geometric representation, but you can also put like this. So if this is a square, all the sides must be the same. So based on the information that we have, each side has length 5 meter by 5 meter. So the area of this square can be calculated by multiplying the lengths and the weights. That means you multiply side by side. So the area becomes 5 meter by 5 meter. Okay, 5 times 5 is 25. 25. Meter by meter is meter square. We usually use meter square or centimeter square or kilometer square to describe the unit of that quantity. Okay, so the area of the square becomes 25 meter square for this specific example. So let me add one more example regarding the square issue. Okay. The third example, in the third example, if the length of a square is doubled, if the length of a square is doubled, by how much the area of the square is changed. Okay. in the third example, we have a certain conceptual question. Here, there is no side given, there is no area given for a certain particular square, but it says only if the length of the square of, if the length of a square is doubled, by how much the area of the square is changed, right? So here we will follow a certain general approach to compare the area of the original square with the area of the newly obtained square region, right? Good. So to answer this, we need to properly put the dimension of the original square and the newly obtained square. So let x be the side of the original square, the original square region. Okay, here I'm representing x as the side of the original square region. So based on this notation, area of the original square becomes a is equals to x squared, where a is the area of the original square. The original square. Okay, here we have x, which is the side of the original square, and a, capital A, is the area of the original square. Okay, we have this notation. Now we need to calculate the newly obtained square region and the side. Okay, let's say let y be the side of the new square region. The new square region. Now, if we are saying y is the side of the new square region, this y is twice of the old one, okay? Because we said here the given information says if the side is doubled. So that means if y is twice of the original square. So based on this, we can calculate the area of the newly obtained square region. So say A prime is a notation that we use for the area of the new square region. So this A prime becomes y times y, because the new square region is the area of the new square region is the product of the sides of that square. So it becomes y times y, but y is 2 times x. Okay? So again, in place of this y, substitute 2 times x. This product becomes 4 times x squared. Okay? Here, I need you to observe critically this 4 times x squared. Okay? Here, this x squared is the amount or the area of the old square. So here, in place of this x squared, you can substitute capital A, which is the area of the old square, right? So here, A prime is 4 times x squared, which means 4 times A. Okay? So we can relate A prime and A in this form. A prime is equal to 4 times A, which means when the when the side of a square is doubled, the area of the new square will be quadrupled, right? Therefore, our answer will be the area of the new square becomes quadrupled. Okay, quadrupled means it becomes fourfold or 4 times the original one. Okay, this is how you answer this kind of question. Well, so these are some of the word problems that we face in calculating areas of something, okay, areas of particularly a square region, right? So next I will show you some examples on how you can apply word problems in cube, okay? Before we start discussing word problems related with cube, I want to tell you roughly about the geometric shape of a cube. Okay, a cube is a solid figure, a 3-dimensional solid figure having this kind of shape. Okay, each faces are the same. Okay, so this is not accurate sketch, but roughly a solid figure of a cube have this kind of shape, and each edge will have the same length. Okay, the length, width, and the height are the same in a cube. So, saying this, there is a relationship between the side of a cube and the volume of a cube. As you all know from your previous grade level, volume is the base times height. Okay, here the base contains the length and width. Okay, there is length times width in the base. Okay, so it becomes the product of 3 things. Okay, the volume of a certain box is the product of the length, width times height. But all the lengths, width, and heights are the same, say x. So this result becomes x times x times x. Okay, so this product becomes x to the power of 3. So the volume of a cube is given by this formula. Okay, whenever you want to calculate the volume of a cube, use the formula V is equals to x cubed, where this V is a shorthand notation that we use to represent the volume. Okay, when I say V, by default you understand that V is a notation that I use to represent the volume. So if volume is calculated in this way, how do we calculate the side of the cube? Well, you need to apply the concept that we used to calculate the side of the cube. You need to apply the concept that we used in our previous lesson. We have seen how the cube of a number is calculated. We have seen how the cubed root of a number is calculated in our previous lesson. So, based on that concept, you can take this equation both sides by cube root, then x becomes cubed root of v. Okay, so use this formula to calculate the volume, and use this formula to calculate the side of the cube. So we will apply these 2 formulas to calculate problems related with cube. Okay, let's see some examples. If the volume of a cube is, if the volume of a cube is 64 meter cube, find the length of the side of the cube. Okay, here to analyze or interpret this problem, it's not a must to sketch the diagrammatic representation of the problem. You know what cube looks like. Then you need to remember the formula that we use to calculate the volume in terms of x, in terms of the side, and vice versa. Okay, so when we come to the first example, what is given? The volume of a cube is given. Okay, the volume of a cube is given, which is 64 meter cube. Okay, it's given that the volume is 64 meter cube, and the required thing here is we are asked to calculate the side. Say x represents the side of the cube. You can make it y, you can make it a, whatever, okay? But you need to follow the formula that we used to calculate the volume. So let x be the side, then we need x. Okay, so what should I do to calculate this x? Okay, we used x is equals to cubed root of v, okay? And v is x cubed, that means x becomes cubed root of v. So x becomes cubed root of 64 meter cube, okay? To calculate the cubed root of 64, the easy way is change this 64 in a certain perfect cube. Obviously, 64 is both perfect square and perfect cube. Okay, you can write 64 as 8 square, and you can write 64 as 4 cube. Okay, 8 times 8 or 4 times 4 times 4. Since this is a cube root, you need to substitute 4 cube in place of 64. So it becomes 4 to the power of 3 meter cube. Now, this cube root becomes 4 meter, okay? So the cube root of 64 is 4. So now the length of the side of this cube, whose volume is 64, is 4 meter, okay? Well, let me give you another example. A cubic fuel tanker has a volume 27 meter cube. What is the depth of the fuel? Okay, here there is a fuel tanker whose shape is a cubic shape, and that fuel tanker has a volume of 27 meter cube. So based on this information, you are asked to calculate the depth of the fuel, right? Meaning that you are asked to calculate one of the lengths of the sides. So So to calculate this, as usual, we put the given information properly. So the volume of this tanker is 27 meter cube, and the required thing is the depth. Okay, the depth of the fuel. Say X. Let's say X is the depth of the fuel. Okay. Say X is the depth of the fuel. So we can now calculate the depth of the fuel using the formula X is equals to cubed root of V, or X is equals to cubed root of 27 meter cube. Okay? To calculate this cubed root of 27 meter cube, the first thing that you need to do is convert 27 in a certain perfect cube, if possible. If not, you put that number as it is, okay? But 27 is a perfect cube. You can write 27 in this form, 3 cube. So this becomes cube root of 3 cube meter cube. So now this becomes 3 meter. So this figure tells us, or this number tells us, the depth of the fuel. Okay? Good. Let me give you one more example, more conceptual. Let's see one more example regarding the cube. Then that will be the end of the present lesson. So the third example is if the side of a cube is doubled, by how much the volume of the cube is changed. Okay. Let me remind you one thing that we did before. We've seen a certain thing regarding the comparison of a square when the side of the square is changed. In our previous example, we've seen when the side of a square is doubled, the area of the new square will be quadrupled, right? So when we come to the cube part, what will happen? If the side of a cube is doubled, what will happen for the volume? By how much the volume of the cube will be changed, right? So we will follow the same procedure that we did for this example. Okay, so here is the procedure. Let X be the side of the original cube, and V be the volume of the original cube. So we don't have a certain exact number for the side of the cube, and we don't have a certain value for the volume of the original cube. So we can roughly represent the side by X and the volume by capital V for the original cube. So if X and V are given, we know that V becomes X cube. Okay, take this thing as it is. Now we are going to calculate the newly obtained cube based on the information that we have here. So let y be the length of the side of the new cube, okay, if y is the length of the side of the new cube, meaning that this y should be twice x, because x is doubled, so this y should be 2 times x, okay? Keep this thing as another important equation. Now we need to represent the volume of the newly obtained cube by another variable. So capital V is the volume of the original cube. Say, let's say V prime be the volume of the new cube, So if V prime is the volume of the new cube, this V prime should be the product of this y, okay? That product is y cube, okay? So now we can represent V prime in terms of V in this way. So y cube means y times y, or in place of this y, in place of each y, you can replace 2x, okay? Substitute 2x in each y. So 2x times 2x times 2x, the product of all these three terms becomes 8 times 2 times 2 is 4, 4 times 2 is 8. So this x times x times x becomes x cubed, okay? Now we are able to express the new volume in terms of x cube, okay? So this x cube is the same as capital V, which is the volume of the original cube. So the new cube can be calculated by 8 times x cube, which is V, okay? So when the length of the side of a cube is doubled, the volume will be increased by 8 times, right? So this is how we answer this kind of problems. Okay, to check this, you can take a certain number, okay, give number for the original cube, okay, you can give a certain amount for the side of the original cube and calculate the volume, and then double it, compare the newly obtained volume. Whenever you compare those two volumes, you can see that the newly obtained volume becomes 8 times the original one, okay? So this is how we calculate problems related with squares and square roots, squares and cubes, right? So I hope you got some more interesting and practical applications on squares and cubes. This is all for today. I hope you enjoyed the lesson. Based on what we have seen so far, I will give you a certain homework. Don't forget to attempt all the questions. So here are your homework. The first one, if the area of a square is 100 meters square, find the length of the square. The length of the square. So this is the first question. The second one is if the length of the square is, if the length of the square is 7 meters, find the area of the square. Okay, this is your second question. The third one is about a question related with a cube. If the volume of the cube is, if the volume of a cube is 216 meter cube, find the side of the cube. And the last question is, if the side of the cube is 10 meter, find or calculate the volume of the cube. So these are your homework. Don't forget to attempt all the questions. Thank you very much. This is all for today.
Dr. Jacobson?
Yes?
We need you urgently in OR3.
No, can do. I'm doing number 4 at 1.
Sir, it's urgent. We have a ruptured kidney.